Hello everyone, welcome to Clean Coder YouTube channel. Today we are going to solve lead code problem number 199, a binary tree right side view. Again, this is a medium level problem and this is a very widely asked problem for interviews, so I'll request you to please pay kind attention. So let's start with the problem statement. Uh, Given the root of a binary tree, imagine yourself standing on the right side of it. Return the values of the nodes you can see ordered from top to bottom. Okay, sure. So we need to assume ourselves standing here and we are seeing this binary tree from the right side. So what would the answer be in that case? Answer would be 1, 3, 4 ordered from top to bottom. So answer is 1, 3, 4. So okay, so 2 and 5 are not coming. Why? 2 and 5 are not coming because 2 would be behind the 3 and 5 would be behind the 4. And from if we see it from the right side, we won't be able to see 2 and 5. So if you got this crux of the algorithm, you would be able to solve this. So let's browse this problem a bit for the constraints. So the number of nodes in the tree is in the range of 0 to 100 and values are between -100 to +100. Cool. Let's move to our whiteboard now. Let me go through the first sample test case and we'll try to apply some algorithm there. So this is the first sample test case. So first of all, what is the right side view of this tree? It's pretty simple. Uh, this one is this one is in right side view for sure. From top to bottom, this one is in right side, this one is in right side, this one is in right side, this one is in right side view. So the answer from top to bottom is 1, 3, okay, 5, 7. Okay. So this is the answer. Now how, like which kind of traversal I need to apply so that I'll be able to store this answer easily in, let's say, any array. So if we see this carefully, what I actually need is I need to apply a pre-order kind of traversal, but but pre-order traversal modified. It's modified in the sense that I am visiting the right before left part. Okay, this is the slight modification which you need to do. And if you got this crux of the algorithm, you can pause this video and you can try to solve this code, this program on your own, and you will be able to solve this because this is the crux of the algorithm. So let's move to the next example to confirm our assumptions. So this is the second test case, and for the sake of convenience, I've already drawn horizontal and vertical lines. So let's get started with the algorithm I've told in the last example. So if we are standing here, let's say answer array is this. I'll store the answer in this manner, here, here, and here. Okay. So let's say I started from this root node 1. Okay. So this level I am encountering for the first time. So definitely this is in the answer array. So 1 I'll write directly here. Now what I am doing? I am doing a pre-order kind of traversal, but visiting the right part before the left part. So I'll go here and I'll visit this 3 and again I'm visiting this for the first time. So definitely this is in the answer and I'll directly write this 1, 3 and I'll move to the right part. So the right part of this is this. Again, this level I'm encountering for the first time and yep, it would also be in the answer. So this I also would write in the answer directly. Now what would happen? Now backtracking would happen and I'll visit 6, right? But you can see that this in this vertical distance of 2 in this horizontal like in this horizontal line, right? This is already covered. Okay, so when I'll visit this, I'll ignore this because the answer for this this horizontal line is already there, right? 7 is the answer, and we are interested in the right side view. So this I'll ignore. Similarly, backtracking would happen, and I'll visit 2. Again, for this horizontal line, this is already covered, so I'll ignore this. Again, I'll visit 5. Again, for this horizontal line, I'll ignore this, and I'll visit 4. For this horizontal line, I'll ignore. Okay, so the answer is 137. 137. This is the answer. Okay, let's see the third example. I hope you have got the gist of the algorithm from here, but even if you haven't got it, I'll explain you with one more example for better understanding. Okay, now like let's do this example slowly so that everyone is on the same page. So first of all, 1, 2, 4, 3, 5, 6. This is our binary tree. Let me draw the horizontal lines. I'll call them vertical distance 0, vertical distance 1, vertical distance 2, vertical distance 3. And similarly, I'll call the horizontal lines as, let me correct this. These are actually horizontal distance. This is horizontal distance 0. This horizontal distance -1. This horizontal distance -2, and this is horizontal distance -3. These are the vertical lines. Okay, these are the horizontal lines. So let's start our algorithm now. We'll start from this. We are trying modified pre-ordered reversal, visiting the right before left. So 1 we are visiting for the first time. Definitely this is in the answer. So I'll directly write 1 here. So right, there is no right here. So I'll move to the left. So I'll come to 2. In this I am visiting for the first time. So definitely this is in the answer. So since I am applying modified pre-ordered reversal, visiting right before left, so I'll go to here. 4. Okay. Again, 4 is in the answer because I am visiting this level for the first time. So there is no right here. I'll backtrack and move to left. Again, for vertical distance equals to 3 of this level, I'm visiting this for the first time. So definitely this is in the answer. Now a backtracking would happen, but this is the answer, and we won't be modifying or we won't be overwriting this array. So the answer for this test case is 1, 2, 4, 5. So I hope you have got the gist of the algorithm till here, and for the sake of completion of this tutorial, I'll show you the code which I used to submit for this problem. So in the next slide, there is the code written which I used to submit this problem for your reference. Okay, so let's go through this code also once. So this is the function right side view which they have given to us. This list of integer L is our answer. Okay, I'll return L in the last. So if root is null, this is a kind of base case is covered here. You need not use hash map. You can ignore this line. I was experimenting with hash map, but it's not required in this problem. So int array new int 1. Why I am using this? This is nothing but a kind of variable. I am using array of size 1 to keep the count of the deepest level visited till now. Okay, so this is being used for that purpose, and initially the deepest level is -1. It's kind of what I say, uh, like just a base taken. Okay, so this is the recursive function. Root is the root of the binary search tree. L is the answer list. 0 is horizontal distance. This is vertical distance, and array is the deepest level we have visited till now, which I have told you. Okay, this is array of size 1 max. So let's come to this recursive function now. It is nothing but a pre-order kind of traversal, but visiting the right part before the left part. Okay, this is the right part, this is the left part. Now let's come to this base condition. Okay, you need to pay very close attention to this base condition. What does it say? So if vertical distance is maximum of 0, vertical distance is greater than maximum of 0. Maximum of 0 is an array which stores maximum depth explored till now. Okay, So if I am encountering a level for the first time, definitely the element at which I am encountering, that I need to put that in the answer. So I am doing L dot add root dot value. So this will put that element in the answer. And if that level is already explored, VD is less than equal to max of 0 case. In that case, I can ignore, because on that level, the recursion would have already put the element earlier in the answer list. So at the end, I am updating the maximum level with the current vertical distance. Okay. So why I'm using array here instead of a variable? The answer is simple. In Java, uh, if you want to do something like pass by reference, you can either use wrapper classes, or you can use an array of size 1. So I'm using an array of size 1. So you can do whatever you like to do. So let's move to the time and space complexity analysis for this algorithm. So time complexity is quite straightforward. It's O of n. We are only doing a single pass of the algorithm. So time complexity is pretty straightforward. It's O of n. Space complexity is also O of space complexity is O of log of n actually. Why it's O of log of n? Because you can write here O of h actually. H is proportional to the height of the binary tree. So this is the space complexity of this problem. So roughly we can say that roughly h is proportional to log of n. Okay, so this relation is generally true. So you can write something like this. This is all I wanted to talk about for this problem. If you like this tutorial, please consider subscribing to my channel. Please do comment if you really like this tutorial. If you have any doubts, you can also put them in the comment section, and I'll try my best to answer them. Till then, goodbye and have a great day. Thanks a lot.